Okay, tak ada, tak apa. Dan nampak slide kan? Can you see the slide?
Okay, Doktor. Okay, Doktor.
Alright, so thank you very much for responding. Alright, so kita dah pergi kepada example of type of adsorbent, and then we move on to the little bit of application, and then regeneration method. Okay, and then kita akan start dengan isotherm. Alright, so normally when I start class, I'm gonna give like allow 5 to 10 minutes kalau ada question yang you want to ask related to previous punya class. Kalau tak ada, then I can proceed. Okay, I assume that you all dah buat revision and then understand about the topics. So that is my assumption lah. So kalau you tak buat revision and then you thought that you understand, tu is beyond my control. Alright, so I try my best just to allow, kalau nak tanya, kita tanya, and then kita try to clarify before kita start new subtopics, because I don't want that you are in a situation that you not really understand but you do, and sometimes you also akan ada masalah, mungkin you tak tahu apa nak tanya. Okay, when you do not know what to ask, you can start to you look back to your material and then you try to note down, okay, do you understand that the things that in the material? If you don't understand, try to write a simple question. Okay, kenapa macam why is supposed to be like this, or why is not like that? So that also you can ask later on during class. Okay, that is how you can start with. Kalau kata tak tahu apa nak tanya, sedangkan you tak faham. You tak faham. Jadi bila you tak faham langsung, and then you pun tak tahu apa nak tanya sebab you tak faham. So you can start dengan tengok line by line, slowly on the PowerPoint material tu, tengok page tu. Okay, kat mana yang you tak faham, identify it. Okay, then you boleh buat marking and so on, and then you try to come up with very simple question you nak tanya. Nanti dalam kelas you tanya. Okay, jangan simpan. Do not keep yourself and you thought that you will try to understand it near to test or final exam. So you dah lupa sangat dah. Alright, so okay. So without further ado, so kita akan start dengan isotherm. Okay, to give you a highlight, dalam adsorption ni, the calculation basically involve two important things that you need to know. Alright, so ada tak slide? Boleh pula. Alright, so two things. One is isotherm. Okay, dalam adsorption, two calculation lah. Important calculation that you need to know in the problem solving and how to calculate and how to solve it. Secondly is design of adsorbent bed. Okay, adsorbent bed ni maknanya kita ada adsorbent. So what is the height, the total height or effective height and so on. So this one kita nak kena calculate it. So these two things yang very important. Alright, so today kita akan pergi dekat isotherm and we see how kita boleh move on kepada yang the rest or not. The second one, okay, this is important. Okay, isotherm is basically kalau you, let's say you ada, mungkin some of you already took chemical reaction, okay, CRE, chemical reaction engineering, right? So dalam CRE you learn about the reaction kinetics. Okay, first order, second order. This is like revision lah kalau you dah ambil. Okay, so dalam adsorption kita tak panggil dia reaction kinetics, but we call it as isotherm. Okay, so this is basically dia punya kinetics lah, but in adsorption we call it isotherm. So isotherm ni, kalau dalam reaction you ada first order, second order, third order and so on, but dalam adsorption we call it the name lah. The name, like for example linear, Frunlich, Langmuir. So normally dia ada nama. So the name is basically name of the people that found it, discovered it. Okay, discover the equation, then they put the name. Okay, the name after that. So not like a reaction, you have first order, second order, third order. So it's very simple. Just remember about the order. But in adsorption, no. So it's related to the scientists that discover it. Alright. So in this particular subject, we're gonna learn about 3 isotherm type. Okay. So you ada linear, Frunrich, and Lamoué. But basically, there are also a lot others of isotherm model. Okay. Other than that, ni Lamoué, Frunrich, you already heard about it. So kita ada juga Dominin, Temkin, Hagin, Hill, Peterson, and others. Okay. Semuanya nama ni adalah, you see that the name of the scientist that discovered it. Okay, ni ada ada isotherm type. So yang kita akan fokus ni 2 lah. And then linear, ada 3. Okay, so dalam isotherm ni, macam mana kita nak gunakan dia? How we want to use it? Okay, it's like chemical reaction juga. Chemical reaction, you ada data. Daripada data tu, you akan buat correlation and then you test. You akan confirmkan that is first order, second order, or third order. So it's the same thing apply dengan adsorption. How you want to know that which isotherm that relate to that adsorption punya process. So you kena test one by one. Kena test linear, kena test Frunrich, kena test Lamoué. So it's not like you ada data, oh this is straight away Lamoué. No, you have to test it. Okay, you have to test it and to confirm. Okay, the data obtained from this adsorption process is basically in line with Lamoué isotherm. Something like that lah, you punya conclusion. So, macam mana nak test dia? Okay, so this is the equation. Kalau linear is Q equal to Kc, Frunrich is Q equal to Kcn, Lamoué is Q equal to Q naught C over K plus C. So, kalau you tengok, biasanya you kena ada data apa? What data you need to know? Okay, you need to have data between Q and C. What is Q? Q is basically this one, the loading. Okay, Q is equal to loading. What loading? Adsorption loading. So adsorption loading, the unit is basically this one. The mass of adsorbate over mass of adsorbent. So maknanya adsorbate ni adalah solute ataupun compound yang you want to absorb. Alright. So katalah you ada 1 kilo of adsorbent. You need to know berapa banyak, how much adsorbate can be absorbed dalam 1 kilo. 500 gram ke? 1 kilo adsorbate ke? So that's data you need to know. So that is referring to Q. When I mention about Q in adsorption, that is the adsorption loading. So meaning that is the mass of adsorbate over mass of adsorbent. So as you use more adsorbent, so you can absorb more. That is normal lah kan? Contoh macam example you ada tissue and then you ada spill water. Setelah spill water tu 1 liter. So, kalau you use less tissue, so that tissue is not enough lah to absorb all. But if you have more tissue, then you can absorb most of the spill water. So something like that. So if you have more adsorbent, you can absorb more adsorbate. Okay, adsorbate ni dia equal to solute. Alright. So bila you ada Q and C ni, okay, normally you akan plot lah. You will plot the graph and then you can see the trend. Let's say kalau you plot and then you draw that line, the graph. Okay, remember dalam exam semua, even is online exam, test dengan final exam, if you happen to be that they have a graph punya question, you cannot use Excel. Okay, you cannot use Excel. Again, you cannot use Excel. Because ada student yang tanya saya, previous semester, the other semester pun sama. The past year punya semester pun student tanya because of online, can we use Excel? The answer is no. Okay, but during class hour, you nak buat exercise, you boleh pakai Excel, no problem, it's allowed. But during test, final exam, not allowed. Okay, please remember that. Do not ask me such question again. Okay, so bila you plot Q and C ni daripada data, mana dapat data ni? Where you get this Q and C? Normally it's from experiment. Okay, they're gonna provide you from experiment. You run experiment or they give you, kalau ada question, dia akan bagi you data ni. Ataupun if they not give you data, maybe they give you equation. So from equation you can plot lah. you try to put one value and then you get another value. Put another second value, you get another second value. Something like that. You have a table and then you plot it. Okay, from this one, bila you plot, you see that this line, kalau you nampak this line is linear, so this is linear. Linear mean is straight line lah, y equal to mx plus c lah. So that is linear. So straight away you can say that it's confirmed that this is linear isotherm. This one. Okay, kalau you nampak linear, then straight away you can say that, oh, this is linear. Q equal to Kc. So the equation is Q equal to Kc. So what happened? How to confirm that this is linear with certain value? So apa you kena buat? You see that from equation Q equal to Kc, you ada constant dekat K ni. K ni adalah constant. You need to find the value. How to find that value? Q dengan C adalah variable lah, because you punya graph is Q and C. So that's going to be your Y and X. So variable. So K is basically constant. So how to find the K? Kalau linear, so you need to find this slope. Okay, slope here is equal to K value. So you need to find that K value, and finally when you answer that question, answer those questions, you need to answer that, okay, yes, finally it's linear isotherm, and equation for linear is Q equal to value of K times C. Put the value of K that you obtain from the slope. So that is how you want to give a final answer. So the final answer is not end until, oh, this is linear isotherm, finish. No, you need to come up with the equation with the value. Okay, the constant value. Okay, this is linear. Okay, fine. Okay, so far linear. Okay. Okay, so what happened if you plot Q and C? You have the data Q and C, and then you get nonlinear line. Okay, if you get like this, okay, so you see that this is nonlinear. Bila nonlinear, you cannot confirm this is Langmuir or Freundlich, right? Because why? Because kalau you tengok kat sini, if you look into this graph, okay, here you have Freundlich kat sini, Langmuir kat sini. Dua-dua nonlinear, dia ada curve. So the curve ni you cannot differentiate. The curve ni step size is very steep or not. You cannot differentiate. Both of them are nonlinear. So that's why when you are in nonlinear punya graph, you need to test it one by one. Maknanya you kena test lah, Freundlich ke ataupun Langmuir. You need to test one by one. Okay. So how to test? Okay, let's say kita test. Okay, kita tengok sini Freundlich. Let's say kita test Freundlich. You need to test Freundlich. Equation of Freundlich is Q equal to Kcn. Okay, this is equation for Freundlich. So how do you want to test it? You need to linearize this equation. Okay, this equation become linear. So how to linearize this equation? So you pakai log lah. Jadi log Q equal to N log C plus K. Kalau you equalkan, if you equal to dengan equation of Y equal to MX plus C, then you know that, oh, C is here, intercept of K. So X is basically the C lah. M is basically your N, okay, your slope. Y is this one lah. So you ada Y sini, you ada X. So this is axis, Y axis and X axis. So what you need to plot? Okay, in this particular case, you need to plot. Remember, you ada data Q and C here. So from there, you can extend kan you punya table. Sebab dalam linear equation of Freundlich, you kena plot between what? Log Q and log C. So how to do that? So you just logkan lah setiap data ni. Ni log Q, log C, you buat satu lagi, log C. So anything that you have here, you just log it. Log Q1, log Q2, log C1, log C2, and so on. So once you get that log, what you need to do, you plot lah. So sini jadi log Q, sini jadi log C. So this time around, you plot log Q and log C. So you see that, okay, you get linear line or not? Let's say you plot, you dapat linear. Okay, so linear maknanya dia sama lah tally dengan linearized equation ni. Okay, okay, let's say you dapat linear. Okay, you nampak dia linear. Linear ni nak tahu dia linear ke tak, dia straight line lah. Kalau you pakai Excel tu, you boleh keluarkan R squared. You can produce the R squared if the R squared is more than 0.9 or 99 something. So that is basically a linear punya line. Okay, a good linear line. So from here, from the plot of log Q and log C, you get this straight line. Let's say you get straight line. Then you can see that, okay, that the adsorption process is follow the Freundlich isotherm. So now you need to produce the equation. You know the equation is Q equal to KCN kan? So you kena dapatkan constant dia. Constant of what? What is constant? K dengan N. So macam mana nak dapat? Okay, daripada sini, daripada log Q and log C, you know that the slope is basically is equal to N. So here N. Okay? And intercept here, this is the intercept, is basically equal to what? Intercept is equal to K. Oh sorry, log K sini. And log C plus log K. So this is equal to log K, your intercept here. So log K ni you anti-log lah. Anti-log, you get K. So once you get the K value, you put it here. And once you get the N value, you put it here. So then you can declare that Q equal to certain value of K, C power, the N value. Alright, with the value of constant. Okay, this is if it's when you plot the graph log Q and log C is linear. Okay, then you can confirm that okay, the final answer the isotherm is Freundlich. The equation is Q equal to katalah 5 C power 7. Let's say. Okay, I just give example lah. Bila you dah find out the punya value. Okay, dia ada juga case whereby mana saya punya ni? Okay, there's a case that when you plot this one, when you plot, you get something like still nonlinear. Okay, you plot nonlinear. So bila nonlinear, so meaning that this is not Freundlich. Okay, so suppose that this is linear equation, but this is not linear, then you get nonlinear. So this is not Freundlich. So what you need to do next? You test dengan Langmuir pula. Okay, you know that equation for Langmuir, Q equal to Q naught C divided by K plus C. Sorry, is plus C, rest. K plus C. Okay, you test dengan Langmuir. Okay, sebelum I test Langmuir, ada question tak pasal Langmuir Freundlich tadi? Bila you dah test Freundlich, katalah you test Freundlich, you buat linear equation log Q log C, and then you get linear. Then you confirm that this is linear isotherm, and then you can come up dengan general equation. And that itu first case. Second case, you test dengan log Q log C, and then you buat plot, and then it's non-linear. So you say that oh, this is not Freundlich, then you need to test Langmuir. Okay. So when you want to test Langmuir, again you kena linearkan equation ni. Linearize this equation. So how to linearize this equation? You can inverse 1 over Q of K plus C divided by Q naught C. So 1 over Q, you separate kan 1 by 1 plus C divided by Q naught C. So you potong C ni. Then you get K over K naught C plus 1 over Q naught. Okay, if you compare this one dengan equation of linear, Y equal to mx plus C, you know that y-axis is basically 1 over Q, x-axis is basically 1 over C here, m is basically K divided by Q naught, and intercept is basically 1 over Q naught. Okay, this is how you want to relate dengan y equal to mx plus C. So here you see that y and x is basically 1 over Q, x is 1 over C. So what you need to plot is basically 1 over Q versus 1 over C. So you ada data tadi, ingat tak, you ada data Q, you ada data C kan. Tadi you dah buat log Q, log C. Now you extend kan, you buatlah cari pula 1 over Q dengan 1 over C pula. So So apa you kena buat? Whatever value that you ada kat sini, you just inversekan. Okay. So when you inverse, you can plot now 1 over Q and 1 over C. From this plot, you can just simply plot it, and then if you get a linear line, so you know that the slope is now is equal to K over Q naught, this slope, okay, this slope, and this intercept is basically is equal to 1 over Q naught. Okay, because finally you say that, okay, this is Langmuir. Okay, Langmuir equation is what? Q equal to, what is Q naught? The value times C divide by, what is the K value here, plus dengan C. So mana dah dapat Q naught dengan C ni? Daripada sini lah. Q naught dengan K. Alright, you can get the value from line of 1 over Q or 1 over C. Okay, that's how you want to confirm it. Okay, so bila you nak try tu, when you want to try to test, bila you nampak Q dengan C tu is non-linear, so you can test either one. You can start with Langmuir dulu, lepas tu baru start Freundlich, pun tak ada masalah. Or you want to test with Freundlich first and then you go to Langmuir, pun no problem. And let's say happen to be you test Langmuir, first trial you test Langmuir and then it's linear, then okay lah, you no need to go to confirm that Freundlich is non-linear, not the isotherm. It's just enough you test Langmuir, it's linear, no need to confirm that, to do a calculation to confirm Freundlich is not the one. Okay, just enough one. Kalau you lucky lah, if you lucky enough, first trial you dah dapat dah, you hit dia punya apa ni answer. Okay, ada soalan? Ada. I think so far so good, right? Okay, this is in class exercise. You can try. Okay, I think this one also you have it in the I think dalam kalam pun ada saya bagi handout yang tutorial macam in class exercise. Okay, in fact you can try it before coming to class. So then when you start, you can ask question. Okay, during the class hour. So this one is you have concentration C and you have loading. Like I mentioned, loading is Q lah. So you see that the unit is gram of solute ataupun adsorbate over gram of alumina. Alumina is basically one type of adsorbent. Alright, so it's like the Q is solute over mass of solute over mass of adsorbent, or mass of adsorbent, adsorbate over mass of adsorbent. You can call it solute or you can call it adsorbate. Alright, so macam mana nak buat ni? So you just plot lah. You plot C, you plot Q. Okay, dia dah bagi dah C dengan Q ni. So you plot. Okay, normally bila you plot ni, you akan dapat non-linear. Kalau saya tak silap lah. So you test lah one by one. You test dulu Freundlich, you test dulu Langmuir. You see that the Freundlich you're gonna get the linear line or not. If not, you move to Langmuir. Okay, so I don't want to solve it here because you can solve it on your own, and then if you find a problem, then we can discuss it. You can raise up a question next week. Okay, unless you dah try, then you tahu. Okay, this one is not that difficult lah. Alright, so like I mentioned earlier, other than the Langmuir, Freundlich dengan linear, so you also have others like dominate, template and so on. So what the good thing about this table, okay, kenapa ada dalam you punya slide is basically, kalau you tengok sini dia ada equation for non-linear. This is non-linear equation. If you see here, the equation is slightly different dengan yang dalam textbook. Okay, because Langmuir kita adalah Q equal to K, Q naught C divide by K plus C. Kalau you tengok equation ni adalah QC equal to Q naught BCE over 1 over BCE, something like that. Okay, little bit different. So dia ada coefficient dekat depan dia. But it's okay because of what? because here dalam linear form dia pun ada juga produce that yang coefficient sekali. So untuk plot ni adalah CE divided by QC equal to 1 over something lah. This is linear form. So kalau tengok yang ni, kita kena plot 1 over Q versus 1 over C. Tapi dalam ni, you kena plot between CE over QE versus CE. So dia punya, oh sorry, dia ada dua. Okay, you boleh pakai ni. Ini sama lah ni. So dia ada dua form. Ada beberapa form sebenarnya dia punya ni. Beberapa jenis. Tapi yang sama adalah yang dekat second one. Okay, just use the second one. Because that one is just, they are combining a few parameter. Sebab you kena tahu what is the Q. Q, macam contoh this one. Q besar ni kan. Big Q. What is that? So dia adalah definition dia. But, just ignore it. So you just find the one that is closest to you. Yang kita biasa pakai. Okay. So yang lain yang sama adalah macam ni. Adalah sama. Alright. Cuma dia pakai KE something lah. But it's okay, no problem. Kita ada C power N. Okay, kita punya Frunish adalah Q equal to KC power N. So ni adalah 1 over N. But it's okay because dia akan buat form dia macam ni. Macam kita adalah N log C. So dia ada 1 over N log C. So no problem. Okay. You akan dapat jawapan yang sama je nanti. Okay. Because their different is little bit different. But finally, the answer will be the same. Okay, so yang lain-lain pun you ada dominate, template and so on. Dia ada dia punya null linear equation. And ada juga linear. And what need to be plot. Okay, so this table is very easy. Sampai you dapat linearized equation. No need to linearize it. Because they already produce it for you. And what plot that you need to plot. Okay, the graph that you need to draw. Alright. So this is just for your references. So that you, in future, maybe you are doing something like in absorption experiment or in your RP and so on, then you know that, oh, okay, I know that it's not only Langmuir, Fröhlich and linear, but also you can have others, right? All right, this table show that certain adsorbent and adsorbate. Adsorbent and adsorbate meaning that adsorbent tu dia boleh absorb apa. Okay, and what is the isotherm? Ni dah confirmed by researcher lah. What is the isotherm related to that system lah. So this system ni. So what is the isotherm related? For example, okay, do not hold that the one adsorption process only have one isotherm. Okay, do not have that in mind because if you see this table, most of the adsorbent and adsorbate having more than one isotherm. Example, you ada pit kat sini. You punya adsorbent is pit. You want to remove divalent metal ion, for example, and the isotherm could be Fröhlich, Langmuir, Reddy-Peterson, Temkin, Duminit, and Toth. You see that you have 1, 2, 3, 4, 5, 6 isotherm that could be associated, can describe the isotherm of this adsorbent and also adsorbate. Alright. But the thing is, how you want to know that which one is the best one? It's very simple. Kalau you pakai Excel, you tengok which one that give the best R squared value. Which one that give like 0.9999. So that is the best among the best. How do you want to select? Okay. Okay, that is, you can see that through that the rest others macam mana you ada adsorbent and also the isotherm that related to them. Okay, so this is another example, batch test, and then you want to determine the isotherm. So this is like in your textbook lah. You boleh tengok you punya textbook how you want to solve it. So it's like that exercise, more or less the same because you have like Q and C at sini. You just plot it and then you test one by one, right? So question, the question tak so far? So far, so good?
Faham, Doktor.
Faham Okay. So normally dalam absorption ni ramai orang boleh score lah. Normally dalam test ke, dalam assignment ke, dalam final exam ke kalau dia ada. Tapi unfortunately there is not in the final exam, it's only in the test. Okay, so kita pergi kepada batch adsorption pula. So what is the function of this batch adsorption experiment? So it's very simple. Okay, batch adsorption experiment ni is basically how you run this batch experiment. I explain dulu how you run this batch experiment and what is the function later on. Okay, batch experiment is very simple. You run macam mana? You ada like beaker, you boleh pergi kat lab, you ada beaker, and then you put your adsorbent here. Tak kisahlah you punya adsorbent is like activated carbon ke apa ke, tapi before you put your adsorbent, you kena timbang dia, berapa mass dia. What is the mass? Okay, mass of adsorbent. You mesti tahu kan, you timbang, you masuklah loaded dalam beaker ni. Okay, you need to know. Okay, dalam batch experiment, this is the important data. So, and then you akan fill out dengan liquid. Okay, liquid tu contohlah you masuk water lah. Water tu yang ada, you tahu dia punya volume. Let's say this is your punya volume. The volume could be like 2 liter for example. Volume you kena tahulah volume. And dalam volume ni you spike. You imitate certain solute that you want to absorb. Like say you nak absorb apa? Contoh you absorb metal lah, metal iron, calcium. Okay, let's say you put calcium. So you can take this sample and then you know that the concentration of calcium. Okay, initial concentration mula-mula. This is initial. Okay, macam mana nak tahu? You take sample from that liquid and then you analyze lah. You guna analyzer. Setelah analyzer, then you know the concentration. So dalam batch experiment ni, bila dah put all this liquid and also adsorbent, what you do next is you just agitate it. So this is agitator lah basically. You agitate it for maybe 2 hours, 4 hours ke, depends lah, until you think that it's already reached equilibrium. Okay, so once you stop, okay, you thought that you reached the equilibrium, you stop. So what happened? You take out sample from here and then you try to analyze the final. Final. Okay, the last. So you know that the final one. But in this particular case, sometimes it takes time. Okay, you want to take sample and then analyze the final, then it takes time. So, and then that final mungkin belum sampai equilibrium. Probably, because you tak tahu how long it's going to take. So what happens is that you can generate a mass balance equation. Material balance means mass balance equation of this adsorption batch experiment. Okay, you come up dengan equation. So in equal to out. You see that what is coming in? This one. But remember that I said you have mass of adsorbent, and then that adsorbent could have concentration of solute. Could have. Macam mana dia boleh ada? Katalah you pakai recycle or regenerated punya adsorbent. Bila you regen, there's still leftover or residue of solute remain dalam that adsorbent. But if you use fresh adsorbent, normally there is no solute in there. Kosong lah kan? Betul tak? Saya salah. Normally it's zero. You are using fresh adsorbent. And initially, masa you start experiment kan, you put your load with the adsorbent and then you put your liquid, right? Liquid yang you tahu initial concentration. So this is solution. Solution means that your volume of feed, in this case katalah 2 liter. Okay, tadi kita letak kan. So CF is the initial concentration yang tadi kita ambil mula-mula. So that is at the beginning. Okay, out macam mana? In equal to out. So that is what is going in. So out is after you mix few hours, then you stop. So that is the out. So out you akan ada mass of adsorbent. Okay, I want to ask you, what happened to the mass of adsorbent after few hours? The mass will be the same, or the mass will increase, or the mass will be reduced? Can someone help me to answer that? What is your opinion? Ada orang boleh jawab? What do you think? Okay, it doesn't matter if your answer is wrong. We are learning. Boleh? Seorang? So, saya nak panggil nama. Panggil nama, saya petik je. Better you jawab. Okay, what do you think? The mass of adsorbent. After you mix, dia akan increase, decrease or remain the same?
The mass increase. Remain the same.
Ada jawab remain the same, ada jawab increase. Okay, basically, dia akan remain the same. Okay, sebab apa remain the same? Because you bawa dalam batch. Okay, you are in the batch experiment. So you put, let's say 5 kilo. And then you just mix. Meaning that you mix, you takkan keluarkan beberapa kilo kan. Dia akan still remain dalam tu. Maknanya the mass akan remain the same. If you put 5 kilo, after 2 or 3 hours, it will remain 5 kilo. So the one that change is basically concentration yang absorb. Concentration bukan mass concentration mana yang ni? Yang mana adsorbent akan absorb. They will absorb the solute. Yang tu akan berubah. And then the S, solution punya volume pun tak akan berubah, will not change. If you put 2 liters, it's still 2 liters. Okay, the one that change is concentration. Pasal some concentration initial tadi dah masuk dalam adsorbent. So concentration final akan berkurangan. So basically this is the mass balance. Okay, from this mass balance, if you couple it, okay, dengan, remember that you ada, okay, saya kena draw dulu baru you nampak. Okay, remember that you ada Q dengan C. This is Q dengan C, original data. It's not log Q, log C, 1 over Q, 1 over C, not that one. That one you nak test, foolish ke lama. But initially you're gonna have like Q and C data. Okay, let's say you have this one, this data, Q and C. You remember that you ada tadi mass balance dalam batch experiment. You ada QF M plus TFS equal to QM plus CS, right? So this equation, okay, dengan plot Q dengan C ni, kalau this equation you plot together dalam this graph, you can predict what is your final Q and what is your final concentration without need to take sample and analyze. Okay, need to take sample macam mana? Macam saya cakap tadi, when I mentioned that bila you habis agitate and then you keluarkan sample, you dapat what is the final, kan? So that is take time, and then you never know that you already reach equilibrium ataupun tidak. So the easiest way, kita plot this equation. Macam mana nak plot? So kita akan plot lah. Dia akan plot, dia akan dapat straight line, linear line. So this linear line, bila you plot, dia akan ada intercept. Okay, dia akan ada intercept between Q over C punya plot dengan mass mass balance equation tadi. So bila you ada that intercept, so this is the intercept. So this intercept, kalau you draw line kat bawah ni, you akan dapat value of C final and you akan dapat value of Q final. So you akan dapat value kat sini lah, Q dengan C. You can predict. Okay, Q is what? The maximum loading lah. Maximum loading meaning that you ada 5 kilo for example of adsorbent. How much solute you boleh absorb with that 5 kilo. So you akan dapat prediction kat sini secara theoretically. And then you can also predict what is the final concentration dekat liquid. Ni dia boleh bagi. Kalau you couple, this is mass balance equation. Okay, macam mana nak buat dia? Macam mana nak plot dia? Okay, senang je. Kata tadi kita ada 5 kilo M adsorbent and then kita ada 2 liter solution yang kita ambil. Let's say kita ada initial concentration C initial is about 100, katalah I say 100 mg per liter lah, let's say. Alright, so you ada data ni kan, so you masuk je lah dalam ni feed. Okay, katalah you pakai adsorbent tu fresh. Bila fresh, QF adalah kosong. Okay, there's no solute dalam you punya adsorbent. So what happen? QF M, so QF ni 0, so automatically this one akan 0 lah. Plus CF is 100 mg per liter. So S is 2 liter, katalah 2 kan, equal to Q M is 5 plus, saya kena alih ni sikit, plus 2C. 2 is 2 liters lah. Okay, C. So what happened? So you akan dapat kat sini 200 milligram per liter equal to 5Q plus 2C kan. Alright. Bila you dapat equation ni, so apa you kena buat? You pilih lah, katalah, let's say if Q equal to 0. So maksudlah Q equal to 0 here, C equal to berapa? You dapat 1 point kat sini. 1 point here, let's say. And then you buat another one, C equal to 0, you akan dapat Q equal to what value? So mungkin somewhere around here. And then you dapat 2 point ni, you plot lah. Then dia dapat intercept kat situ. Okay, boleh? Like this lah. So akan dapat, this is material balance line, this is isotherm, yang daripada Q dengan C. And then you dapatlah, you boleh estimate what is the final Q, this is Q, maximum loading, and what is the final concentration dalam liquid you after you end up the best experiment. Okay, question? Tak ada. Okay. Example, let's say example ni, you ada volume is 1 meter cube. So this is your S. Contain 0.21 kilo phenol. So this is concentration of initial 0.21. A total of 1.4 of fresh granular activated carbon. So the M is basically 1.4 kilo activated carbon fresh. So fresh meaning that you punya QF gonna be 0 lah. There's nothing in the adsorbent lah. Dia punya solute. Biasa fresh is 0. Kalau kata dia guna regenerated, maybe you akan ada some value of QF. Alright, so calculate the final equilibrium. So you ada, dia akan pakai example 1211 tu. Okay, 1211 kalau you plot, you akan dapat Q dengan C macam ni lah. Lebih kurang. Alright. So equation ni macam ni you nak come up dia. So you ada QFM plus CFS equal to QM plus CS. So masuklah semua value dia. So this one gonna be 0 because QF is 0. CF 21. S is basically 1 equal to M is 1.4 Q plus S is 1 C. C is nothing. Okay, so C lah. So you dapat equation 0.21 equal to 1.4 Q plus C. So macam saya cakap tadi, if Q equal to 0, you dapat C value. So dapatlah satu kat sini, let's say. If C equal to 0, you dapat Q is certain value sini. And then you just plot. So this is the intercept. So you dapatlah, this is final C, this is final Q. So this is how you want to solve it. You can solve it on your own lah. So this is how roughly how you want to solve this problem. Alright? Okay? Boleh? So kalau okay, kita akan take 5 kejap. Because kita dah finish on the isotherm. Now we move on to fixed bed design. Fixed bed design maknanya kita nak calculate. Kita ada adsorbent. Adsorbent tu kita akan load dalam kolom. So what is the height here? Okay, required height patutnya dalam kolom tu. So this is how you want to calculate it later on. Design of fixed bed adsorption column. Okay, kita take 5. So 10:56 kita akan start balik.